Good morning, students. In the last class, we discussed the potential energy stored in the dipole. That is, a dipole when it is placed in a uniform electric field and non-uniform electric field. In such cases, we discussed. Next, we will go for the next concept called null point or neutral point. Null point or neutral point. The null point or neutral point means the point where the net electric field intensity is 0. That point is called as the null point or neutral point. The point where net electric field intensity is 0, field intensity is 0, that point is called that point is called as a null point. If you take two charges, those two charges, if you take some separation, if you place it those two charges, what happens means those two like charges at the midpoint of at the center of these charges, in between the charges, what will happen means somewhere the electric field intensities due to both the charges are equal in magnitude, opposite in direction will be possible. That time what will happen means at that point the net electric field intensity becomes 0. Let us take here the charge Q1, here charge Q2 is there. These two charges are separated by certain distance here R. Somewhere what will happen means the electric field produced by the charge Q1 as well as the electric field produced by the charge Q2 will be equal and opposite. Then they will be what? Net electric field intensity becomes 0. Where it is happens in between the charges we don't know. Let us take here I am taking that Q1 is greater than Q2. Q1 is greater than Q2. So let us take at a point here. This is at point P. The electric field intensity at point P due to Q1 is away from it. That is electric field intensity due to positive charges away from it. That is E1. The electric field intensity at point P due to Q2 is away from it. That is E2. Now this point P is at a distance, let us take this as a distance x from this charge Q2 charge and r minus x distance from the Q1 charge. Then we can write these two are equal in if they are equal in magnitude, already they are opposite in direction. If they are equal in magnitude, what will happen? These two electric field will be cancelled, and here net electric field becomes 0, and this point we will call it as a null point or neutral point. So if P is a null point, we can write these magnitudes can be equal. Electric field intensity E1 and electric field intensity E2 are equal. So E1 in the sense that is electric field intensity due to charge Q1. So that is we can write 1 upon 4 pi epsilon naught Q1 by distance here is r minus x whole square is equals to 1 upon 4 pi epsilon naught. So Q2 by here distance between these two is x. So x square. So these two common cancelled. Then we can write you wanted the distance x. If you want the distance x, you can rearrange like this. r minus x by x whole square equal to r minus x. If you brought it, then it will be q1 by q2. Then r minus x by x equal to under root of q1 by q2. Then we can write r by x minus 1 is equals to under root of q1 by q2. Then r by x is equals to under root of q1 by q2 plus 1. And the null point distance x is equals to r divided by under root of q1 by q2 plus 1. Okay, so this is the distance from which charge here is from the charge which is having smaller magnitude. You understood one point here. Always null point is possible closer to the smaller magnitude of charge. Why? The reason is here a larger charge is there, the strength obviously it is more. That's why smaller charge is there, that is the strength of the electric field is less. So so these two electric field intensity should be equal in the sense. So the distance should be more from the higher magnitude of charge and less from the lower magnitude of charge. Then only what it is possible, these two electric fields can be equal. If you take closer to the larger magnitude, obviously closer means from the larger magnitude of charge, closer means what happens is obviously strength more, but the strength will be less. That time these two electric fields are not equal. So that's why far from the higher magnitude of charge, closer from the lower magnitude of charge, there is a possibility is there to equal these two electric fields. That's why what will happen means the null point is almost only the very closer to the lower magnitude of charge. Already here I told you q1 is greater than q2, so q2 is a smaller magnitude of charge. That's why here the null point is possible from q2, closer to q2. So this is the formula we have. So here we discussed that this you can remember it always. The denominator what was there, the charge q2 is there here in the denominator. So the distance whatever we will be get here, the distance is corresponds to the the charge which is in the denominator. Okay, or else if you want to find from other charge, means if you take x from q2 we measured, but if you want to measure it from q1, that is also we can do, but that time what you will get here result q2 by q1 will come. Okay, so always the distance is corresponds to whatever distance you are measuring, the distance is corresponds to the charge which is present in the denominator. So here denominator q2 is there means this distance is measured from q2. The denominator q1 is there means this distance is measured from q1. That is the point. Here plus 1 we have. Plus 1 indicates that these two are like charges. If two charges are like charges, so charges are like charges. So here you have to understand, if these two are unlike charges means in place of plus we will get a minus. That is also we can check it here. If you taken the two unlike charges, same kind of unlike charges if you taken, here one is if the charges are unlike, if the charges are unlike, let us take, so one is plus q1, another one is minus q2. They are unlike charges. So q1 is one charge and minus q2 is another charge. So here the same condition, magnitude of the charge q1 is greater than the magnitude of charge q1 is greater than the q2 magnitudes we are taking. When negative charge is there, magnitudes only we have to be considered, whether it is which is larger in magnitude, that is only we should be considered. Now here separation between these two charges is R. See, you observe once. Between the charges now, electric field will not become zero. Why? Because of positive charge, electric field intensity is away from it, that is E1. And because of negative charge, electric field intensity is towards it, that is E2. See, electric field intensity is due to both the charges. Between the both the charges, what is happens here? Between the charges, those are same direction. If same direction is there, they won't be cancelled each other. So where the null point is possible, in the sense where the two electric fields are opposite to each other and magnitude wise they are equal, then there is a chance to cancel. But between the charges, their electric field intensities are both are same direction, so they will not be cancelled between the charges. Means null point will not be possible between the charges. And I told you, now the null point is possible not between the charges, it will be outside of the charges. And I told you here outside means this is possible, this is possible. So where we have to take the null point, in the sense we clearly mentioned that the null point is closer to the smaller magnitude of charge. That's why here, which is smaller magnitude, Q2 is a smaller magnitude. That's why outside, in the sense you should not take outside of Q1. Should take the outside of Q2. Why? Q2 is smaller in magnitude. That's why I am taking a distance, some distance, let is this distance as x. Here you take the point is P here. So at this point P, the electric field intensity due to positive charge Q1. So positive charge Q1 means electric field intensity is away from it, that is E1. Due to negative charges, electric field intensity is towards it, that is E2. Now outside, now what electric field intensities are opposite to each other. So if these two are magnitude wise, if it is equal, then here what will happen? Null point is possible. So what I am doing now is at P, so the null point is possible when when it is possible when magnitude of E1 equal to magnitude of E2. What is magnitude of E1? That is electric field intensity due to positive charge. So totally the distance from Q1 to P is R plus X. So the distance from R plus X. That's why E1, in the sense you can write 1 upon 4 pi epsilon naught Q1 by R plus X whole square equal to 1 upon 4 pi epsilon naught Q2 by, here we can write that from Q2 the distance of P is X, so X square. Now these two will be gets cancelled, then can write as R plus X by X whole square is equals to, you can take it as a Q1 by Q2. Then you will get R plus X by X equal to under root of Q1 by Q2. Then R by X plus 1 is equals to under root of Q1 by Q2. Then R by X is equals to under root of Q1 by Q2 minus 1. Then we wanted the distance X, that is equals to R by root over Q1 by Q2 minus 1. So the previous expression we have plus, but now we have minus. So generally we can write that the null point distance means we can write the null point, this is in minus y, when it is came, unlike charges are there, and outside of the charges electric null point is possible. Like charges means between the charges null point is possible, the time plus will come. So we can make it generalize that null point distance means we can write X is equals to total distance between the charges, where numerator is total distance between the charges by root over q1 by q2 plus or minus 1. I will write here plus 1 indicates that like charges, and minus indicates that unlike charges. So plus you have to take when charges are like, minus you have to take when charges are unlike. This is the thing is about the null point. So let us take one example for it. Let us take, we have 3 microcoulomb as well as the some 12 microcoulomb is there. Then if these two charges are separated by certain distance, we'll take it here. Let us take 3 microcoulomb is one charge, another one is 12 microcoulomb is another charge, and they separated by 1.2 meters. Okay, example we'll do here. Find the point of the line joining the two charges where the resultant field is 0. Find the point on the line joining the two charges. That is one is 12 micro or nano, anything you can take it. 12 nanocoulomb I am taking 12, and another one is plus 3 nanocoulomb, where the resultant electric field is electric field is 0, and the distance between them is distance between the charges is 12, so 1.2 meters we take it, 1.2 meters. See, they given the charges plus 12 as well as plus 3 nano or nano micro, whatever it is there, no issue here. Those are like or unlike, first you have to check it. They are like charges, both are positive. Like charges in the sense in between the charges null point is possible, and distance between them is what, 1.2 meter. So immediately you have an idea that the charges are, one is plus 12 nanocoulomb is one charge, and another one is plus 3 nanocoulomb another charge. Let us take this as q1, let us take this as q2. Then separation between them is 1.2 meter. Then immediately you have to have an idea, always the null point is closer to smaller magnitude of charge, that we discussed already. So here smaller magnitude is nothing but 3 nanocoulomb. So the null point is possible from 3 nanocoulomb charge. So let us take, I am taking the distance is x from the 3 nanocoulomb closer, and the remaining is 1.2 minus x. And procedure wise you can follow, or else we can have the direct formula that x is equals to total distance by under root of x is always nothing but the charge which is present in the denominator. X we are measuring from 3 nanocoulomb, so that is q2. So q2 should be in the denominator, q1 in the numerator. Plus or minus, what we take here is, they are like charges, both are positive, so plus. If there one is positive, another one is negative, means minus 1 we have to write. That's it. Now r is 1.2 meter by under root of q1 is here 12 nanocoulomb by 3 nanocoulomb plus 1. So nano cancelled. So 12 by 3 means 4. 4 under root of 4 means 2. That is 1.2 by root 4 plus 1. That is 3. So 1.2 by 3 means 0.4 meters. So where the null point is possible? 0.4 meters from which charge? Q2. The charge distance corresponds to Q2, that is from plus 3 nanocoulomb. This is the way you can find it out. If suppose if charges are, one is positive, another one is negative, if they given same case, you can understand that if charges are plus 12 nanocoulomb and minus 3 nanocoulomb are given and separated by distance, same distance we are taking, the distance between them is 1.2 meter. So what will happen here if they are we can say if there are unlike charges, separation is 1.2 meters. That time what will happen here is so one is plus 12 nanocoulomb, another one is minus 3 nanocoulomb, separated by 1.2 meter. There are unlike charges in the sense, so what is the formula we have to take? Same formula, but plus minus you have to write. That's it. Then I am writing that x is equals to 1.2 by root over 12 nanocoulomb by 3 nanocoulomb in plus now minus 1. That is 1.2 by what? Root 2 and root 4 means 2 minus 1 means it is 1.2. So x is equals to 1.2 here. Exactly 1.2 means what will happen here is exactly at this point only the electric field intensity is due to these two charges will be equal and opposite. So here only exactly at the second charge only electric field intensities are equal and opposite, that is E1, E2, these are equal and opposite exactly at the second charge, because 1.2 means that is from first charge, that is, we will be discuss it here clearly. Here plus 12 nanocoulomb, here minus 3 nanocoulomb, Q1, Q2. So where the null point is possible means outside. This is at a distance x, we will be take it, and already it is 1.2 meters we have. There we told you unlike in the sense formula x is equals to what? Total distance by under root of what? This is if you take it from, you are measuring from Q2, so Q2 in the denominator, Q1 in the numerator. Minus 1 I have to write. Why? Plus is like charges, unlike charges means minus. It is R in the sense total distance, 1.2 by under root of Q1 in the sense 12 nanocoulomb by, here only magnitude I have to write, okay, don't put any sign here, just magnitude, directions we can know it here. At this point electric field intensity due to E1 and E2 are equal and opposite at point B. Then 3 nanocoulomb minus 1, then 1.2 by under root of 4 minus 1, that is 1.2 meters will come. Means that is 1.2 meters from where? Minus 3 nanocoulomb. So 1.2 meters from minus 3 nanocoulomb, and it is 2.4 because 1.2 plus 1 means 2.4 from 12 nanocoulomb. So the null point is, we can write, therefore the null point is 1.2 from what? Minus 3 nanocoulomb outside of the charges, outside of the charges. That is the thing you have to be understand clearly. This is because a very important concept, and this is the type of problems many times they will ask you in the examinations as well as board wise as well as objective wise. So you have to be clear this one. Simple formula, that is the distance by total distance between the charges by root over q1 by q2 or q2 by q1. Always you have to understand from which charge you are measuring, that charge distance is here. Suppose if you have taken the distance from q1, denominator should be q1. If you are measuring distance from q2, denominator should be q2. And plus or minus 1, plus is both are like charges, minus means when they are unlike charges. That is the point you have to be keep it in mind. Next we can go for if a charged particle is left in an electric field at rest, what will happen? And if the charged particle is projected with an velocity v, so normal to the electric field, what is the deviation produced in it? So such cases will be discussed. Now let us take here another objective wise point. If a charge q is placed in an electric field, then what will happen? So then the velocity, so initially we will place it at rest. The velocity after t seconds, and one more is first one is the velocity of the particle at t seconds, second one is gain in kinetic energy. This is I will be clearly tell you one thing, that if you are taken a uniform electric field, how to produce a uniform electric field in the sense, if you take a two metal plates like this, one is if you make it positively charged, another one is negatively charged, means in between these two metal plates there is a uniform electric field, that is from positive plate to negative plate there is a uniform electric field will be produced. Now a charge q is placed here, which is initially at rest. Positive charge is there, it will experience a force. This electric field intensity is E. Everywhere electric field intensity is E only. Why? This kind of field we called as a uniform electric field. Everywhere the magnitude of electric field intensity remains the same. Now positive charge means it will experience force in the direction of field. That's why this will be experience of force in the direction of field, that is F equal to EQ. So force is experienced means it's going to be accelerate. So F equal to EQ, and we can write A equal to F by M, that is EQ by M. So this will be gets accelerates. What acceleration is EQ by M? So initially it is at rest and it is accelerating with an acceleration EQ by M, means we have equations of motion. From equations of motion, in first year you learned V equal to U plus AT. Initially rest, so initial velocity is 0. Acceleration is EQ by M. So after t seconds, what is the velocity gained by it here? So it is traveling, it is reached here. So after t seconds it taken to reach here. Then velocity, this is how much? The velocity we can find by using the expression V equal to initial velocity is 0, A in the sense EQ by M into time t. This is the velocity after time t seconds. Now the question is, what is the gain in kinetic energy? So gain in kinetic energy in the sense we have that if the gain in initial velocity is 0, U equal to 0. So initial kinetic energy KEI Anyhow, velocity 0 means kinetic energy is 0. Final kinetic energy. Final kinetic energy. Final kinetic energy means KEF equal to half mv square. V already we discussed here. V is nothing but EQ by m into T. That is, we can write half m into EQ by m into T. This is final velocity square. Then you will get half m E square Q square T square by m square. Then it is cancelled. So you can write E square Q square T square by 2m. So this is what final kinetic energy. Therefore, gain in kinetic energy in the sense gain in kinetic energy, that is the delta Ke is nothing but KEF final kinetic energy minus initial kinetic energy, that you will get E square Q square T square by 2e. So this is what we have as gain in kinetic energy when your charge is left at rest in a uniform electric field. This much velocity it gains. Velocity, how much it gains in the sense V equal to EQ by m into T, and how much kinetic energy it gains in the sense E square Q square T square by 2m. This much of kinetic energy it gains. Suppose if the charged particle is projected normally, suppose one more case I am telling you here, just one more point. A uniform electric field is there like this. In this uniform electric field, a charged sphere is held stationary in a uniform electric field, stationary in a charged sphere is held stationary in a uniform electric field, then its radius of the radius. Suppose one sphere I took here, this electric field downwards in charge, in the sense what kind of charge I am taking here is negatively charged sphere I am taking. So negatively charged sphere if I take, so some electrons are present, excess electrons are present, that kind of charged sphere I taken. This sphere is having a radius is r. This sphere is held stationary. The meaning is stationary is what happens, it will be at rest. So any body when it is at rest, the net forces acting on it is 0. Actually, what are the forces experienced by this body in the sense, usually it will come down because of its weight. So weight is the force which is acting downwards. Because of this weight, this will be comes down. But it is stationary in the sense it is balancing. Its weight is balancing. So its weight, how it is balanced means one more force is acting. That force is equivalent to mg. See, this is a negatively charged body. The negatively charged body will experience force in the direction opposite to the field. So this is the force is there. This force F equal to EQ, because negatively charged body experiences force in the direction of opposite to the electric field. When EQ and mg both are equal, then what will happen? This will be stationary. Then that radius, how much you have to be find it out. Its radius, how much you have to find it out. If rho is the density of sphere is given, rho is the density of the sphere they given, and the q is the charge if you taken, then how much of what is the radius of the sphere if they ask. You know, if it is stationary, what is the condition? It is obeying mg equal to EQ. So we can say if the sphere is stationary, you can say mg equal to EQ. But we want the radius of the sphere is how much? So radius, if you want it mass, you can write as a m is equals to density into volume. So density rho, volume means spherical shape, no? Spherical sphere in the sense, so volume is 4 by 3 pi r cube. That if you substitute here, rho 4 by 3 pi r cube into g equal to e cube. Then we have r cube. If you take it, we want r, that's r cube, and remaining if you send it other side, 3 e cube by what? Rho 4 pi g will come. Then r equal to, you will get 3 e cube by what? 4 pi rho g whole raised to 1 by 3. This is the radius of the sphere. So like this you can able to find the radius of the sphere. Sometimes they will give you the charge, how much charge is there, and density of the sphere, electric field intensity means you can able to find it out the radius of the sphere by using this formula. In this you have an example also that will be discussed it. So here I will give you the point, everything information that you have to be solved. This is you for your exercise here. I am giving you the charges information like this is there. What is it? The charge Q equal to some 2 microcoulomb. Electric field intensity E equal to they given as 2.2555 into 10 raised to 4 nanocoulomb Newton per coulomb, and density of the sphere is we can take it as 1.26 gram per cc, and you have a so this information is enough here. E is there, Q rho, G you can take it as a 10 meter per second square. And if the charge sphere is held stationary, you substitute these informations in this and find the radius. Okay, so that is your task, and remaining we will be discussing in the next class.